In the previous lecture, we have discussed about the causality and stability of LTI system, and today we are going to discuss about the unit step response of an LTI system. Previously, we have also discussed about the impulse response of an LTI system. In that, we know that if any signal del t is applied to the LTI system, then output is nothing but the ht convolved with del t. As from the convolution property, if any signal convolve with del t, then the response will be same as a signal ht. This is known as the impulse response, where the input is impulse and the response is known as impulse response. Similarly, when input applied to the system is step, then the output, which is here represented by st, is known as step response. Here the output is equal to ht convolved with ut. As from our discussion, unit step response, the step response del n and del t, Sn and st is defined as the output due to the step input. For the discrete time, it is a un, and for the continuous time, it is a ut. Okay. Then the output response Sn is nothing but the convolution of system behavior convolved with un, step response. If we formulate this, then this equation becomes summation moving from minus infinite to infinite hk un minus k, as un minus k from the here discussion, as we know that if ut or un is defined for 1 when n is greater than or equal to 0 and 0 else, and our need is u n minus k. Therefore, this n represent here and their magnitude represent this and this. Similar case, if n minus k is 1 and 0, where n is replaced with n minus k is greater than or equal to 0 and this is else. And this is also represented as when k is moving that side, then n is greater than or equal to k. Our variable is k, therefore k is same case, therefore it is also written as k is less than or equal to n. Okay, this means un minus k is defined as 1 for the k less than or equal to n, and for k less than or equal to n, and 0 for k greater than n. Okay, therefore it is used here for the changing the limit of this summation. Then if we this is replaced by this limit. Okay, then Sn is defined for k is moving from minus infinite to n, because this magnitude becomes 1 when k is less than n. After that, it is equal to 0. Therefore, this limit is nothing but moving from minus infinite to k minus infinite to n. This is known as the step response. This means if an equation, if impulse response is given, then if we sum that signal from minus infinite to n, then step response will be obtained. And the reverse can also be done. It means if the step response is given, then impulse response we obtain the impulse response. Sn equal to h if we divide it into two parts. One part when we put k is equal to n, here k is nothing but it is k. Then when we put k is equal to n, then n is put here, and this is equal to hn plus, and then summation become k minus infinite to n minus 1 hk. This when we change this limit here, and k is replaced with n is replaced here n minus 1, then this limit become s n minus k, because when n is here, then step response the variable is n. If we change here minus 1, then it become minus 1, then s minus 1. Therefore, the impulse response Hn equal to Sn minus Sn minus 1. Therefore, from these two equations, if impulse response is given, there's a summation. After the summation, then step response will be, we will obtain step response. If step response is given, then we get impulse response. Therefore, the impulse response of discrete time LTI system is nothing but the first difference of step response. This is for the case of discrete time. Similarly, we can obtain for the continuous time. Okay, for the continuous time, this limit minus infinite to infinite h tau u t minus tau. As from the continuous, it is moving from, as for the in case of discrete time, this is moving from minus infinite to n. The same, it will change the limit, and step response become moving from minus infinite to t and h tau d tau. Okay, and this is when impulse response is given, and when we integrate it from minus infinite to t, then we get step response. And reverse can happen, reverse can be obtained by the differential function. It's my first differential function as in case of discrete time. Therefore, unit step response of is the first derivative of the unit step response. Sorry, unit impulse response is the first derivative of the unit step response. Then ht equal to dst upon dt. And for the discrete time, when impulse response is given, we get step response, and if step response is given, then we get a impulse response. Same for the discrete time. When we have a impulse response, we get a step response, and if we have a step response, then we get impulse response. In the next lecture, we will discuss some question based on this.